My name is Hideki Nakajima. This video talk about LG4X, which is my code developed for XPS users to fit the curve or spectrum. The website here in GitHub, you can access all information available for all users and download the code. LG4X represents lmfit graphical user interface for XPS analysis. lmfit is an open source Python package to fit the curve or any spectral data. So I developed graphical user interface especially for XPS user, which called LG4X. You can access the fundamental theory of XPS from this link, and Python. You need Python, so you can download freely from the website. The version now is 3.10 for Mac, Windows, and Linux. lmfit detailed information also available from this link, and especially project link homepage. You can access all information for lmfit package. Basically work on the command line interface, so that's why I developed the graphical interface. Especially you need some download and installation information from here. Let's get back to my home page. What we actually need is the Python 3. So you can download Python 3 or you use the brew to install Python 3. And lmfit package for fitting the curve. Pandas handling the data frame structure, which make me easy to coding. The MATLAB plot library to plot the data in graphical interface, and pyqt5 use the graphical interface design of this program. So you need at least these 3 additional packages need to install by this command. For example, I use Macintosh, open the terminal command, then you can use Python. In the default Python in Macintosh is 2.7, so you need to install Python 3. Python 3 version also installed in this computer already, so the version currently is 3.9.5. So if you need something installed, use pip. So pip version we use, then we can install pip3 install lmfit, something like this. Python pip3, yeah, install lm install lm. Then you can start installation. Actually, I already installed lmfit package. Then information to check lmfit, pip3 show lmfit. So you get the version of the lmfit. So what you can all the information available from pip3 show, and pip3 show pandas, yes, and MATLAB library Python pyqt5 also available in the same way. Then you need this. You need download my code into your PC, Windows or Macintosh or Linux, anywhere, any computer available. So I use Macintosh desktop folder, then save it. It's not very large file. So as you can see, desktop zip file is available. So I unzip the file. You get the whole information as you can see from here. Then what you need to run is, if you have already installed and you need to update the package, you need pip3 install upgrade lmfit. So I mean from the terminal command. So what pip3 install. Then you will see the no such option upgrade. Sorry. So that is already satisfied. So no upgrade necessary. And supplementary code for XPS analysis, such as background subtraction, which is not included in lmfit. So I take some code from blah blah blah. The BAMAS, the ISO standard XPS data format, also available in this code and is already like the code modified from other coder. The periodic table also available to identify the element is actually already in Python directory, as you can see that. This is just the description and acknowledgement for each contribution. So what we need is to start my program from the terminal, python3 main. No. I have to go to the directory, change the directory desktop, and change the directory LG4X, and change the directory LG4X master, and change Python directory. So you get this main py file. Then you can start Python 3. If you have only Python 3 in your computer, you don't need this 3, but the Macintosh has two versions, 2 and 3, so I specify Python 3 to run this main py. It takes some time, especially in the first time to run the code. Okay, so this is what I developed, the LG4X for graphical interface for lmfit. So I would like to explain some more detail first. So this is the version I developed environment. So if you have some problem, you upgrade the package, or if you miss something, you have to install the package. However, Just you need this, and all necessary packages are also installed automatically, so you don't have to additionally install SciencePy or NumPy or the other packages. Then the interface is actually 4 parts. The first quadrant is the interface. We can run some operation, import or choose the background type for fitting and simulation, and save, export your data before or after fitting. Then you have visualize the spectral fitting, and there's a two table. You can modify background parameter, including the range you want to fit. So this is the example. You have a spectral data for carbon 1s, but you want to fit in the limited range. You can also specify the range for fitting. And the fit table, so-called, you can add the number of peaks, add peak or remove the peak, and adjust the peak shape and position of the peak or width of the peak. Number of the peak shape is available, as you will see in the bottom table, like Gaussian, Lorentzian, Hoek, pseudo Hoek, exponential Gaussian, skew Gaussian, skew Hoek, blah blah blah. Usually we use Gaussian, Lorentzian, or pseudo Hoek is actually enough. And if you want to see the detail of this model, you can go to lmfit package detail, so you can get the equation, the parameter detail used for this model. This model has 3 parameters: amplitude, center, sigma. Each corresponding parameter can be optimized in lmfit package. So as you can see here, and go back to the actual interface, you can see the model, Gaussian, Lorentzian. You can choose one of them, and you can set the energy peak position. This peak position, like center of the energy. Sigma is the width parameter, and gamma is not used in the Gaussian, but probably some other model use this gamma. So even if you change, it does not affect to this Gaussian shape. The amplitude is represent amp cell, so you can change this amplitude of the peak. Fraction skew Q also used for the other model. And if you want to add the peak, you can add as you want and remove the peak as you want. And the background table, as I mentioned, that the range of the spectral fitting you can set initial and the end, and the number of points is specified for simulation. I will show you later. Then actually import data from this drop-down menu, the background shape, including the Fermi-Dirac function and the arctangent error function for X-ray absorption spectral fitting, valence band maximum cutoff of the UPS spectra can also be prepared. This file list, after import, you can get the name of the data, and fitting preset can also set the new or load from the previous fit, or you can add some parameter, or you can save the new parameter you want to save. And this is carbon 1 is the default setting, and you can also show periodic table to identify the peak position as a reference. Now we don't have any data, but if you click evaluate, you can evaluate the peak from the current condition, the range to range we set, and the position of the peak here. If you change the Lorentzian shape and evaluate, you can see how Lorentzian shape looks like. Hoik, Sud, Hoik, exponential Gaussian. It's like asymmetric. Skew also asymmetric, but I don't put any skew parameter now. For example, if I don't know this is good or not. Okay. Skew also make a peak asymmetric. This is some kind of also gas phase photoionization, log normal. You need some parameter correctly. So now, simple XPS analysis, we need a Gaussian shape, or you need to something multiple peak. Also, you can simulate the peak without any data importing. I would like to import some data. The data probably I prepare some data in example file, as you can see that. So I choose some example data. For example, PET carbon 1s. So this is how its carbon 1s from PET spectra looks like, as I show you from this website. Then you can see the from the name of the file listed here. And you can evaluate the peak, or you can choose the new and evaluate. So we need more actually data, but you can test fit, so you can see the result immediately. And maybe we need 1, 2, 3 peak at least. So I add the peak, evaluate it. Peak position is slightly different, so I put here, you can see this number, 286. It's okay. No. 86. 6. You can adjust actually manually if the estimated peak shape is quite different from what you can see, then you can evaluate it. So if you don't make this adjustment, the peak fitting will not well converge to the, so you need to make the parameter similar to the data. Then you can try to fit, then you can easily fit the parameters. If you want to change the range, for example, up to 290 and lower to 8. Then you can click here and evaluate. Okay, range is okay, and you can fit. So you can fit only the range we specify here. And if you sometimes you want to fix the width, you can also check this button for something like this. It's not practical, but for example, we fix the width, then fit. So the sigma doesn't change, but all the other parameters try to optimize with this boundary condition. Then, okay. Now the default background is Shari, but you can also toggle. You can change the parameter here and polynomial here. If you want to actually adjust polynomial, you have to unlock the first. Then you can actually optimize this parameter, but now it's not necessary to be complicated now. So Shari backgrounds is enough to fit the current data. The data we can import is just something looks very simple. This is not the XPS format, but actually the first column you may see the binding energy. The second column separated by comma is the intensity. The first row we don't use it, and the second row we use until the end of the text file. The other format, we can also load the text file, but the text, in case of text file, you may use the delimiter as the tab. I will show you later. Some of XPS machine provide ISO or BAMAS format file. Import BAMAS. So BAMAS. I don't have any BAMAS data here. Really? Okay. I think I have some. Okay. So for example, multipack or multipack export NPL file, which is the ISO format, and the same as BAMAS file. This BAMAS file also BAMAS say the same. So you can open, then you can get the file list, additional file list appears here. The white scan is for service scan, which is not normally fit, but if you choose the periodic table, you can identify the peak, or this is carbon, oxygen peak, and OJ peak here. And this might be something nickel and tungsten there. So nickel here. I see nickel is not very, but the tungsten definitely the main component of this sample. If you want to fit carbon S, so this is not, you can new parameter to evaluate and fit, so you can fit the data. It's not very nice, very range. Fit, oh, maybe the range is, for example, the shell doesn't really work. Try again. Some we need to have some boundary condition appropriately. It's too narrow. Okay. One more peak. Probably the peak with probably wider than this, so we may unlock fit. We need some limitation. Something. This is okay. Another peak, oxygen 1s. Oxygen 1s. Okay. Evaluate and fit. It's okay. But the background is a bit, so we use polynomial convolution. So, and we may limit the range. So it's okay. If you want to add more peak, and one more peak, something like this. But you need to limit the width of the peak. Then it looks like you don't need to the third peak, and sometimes it go away. So go. It doesn't look good. You have to adjust to, or you just make a new reset and fit again. So sometimes amplitude go negative, or the peak position is go away from far, very much away from what actually you want. So you have to adjust carefully before click the fit, and you can actually save the data and the other sample data. You can also load this preset for next sample files. This file imported is exported as a file, as you can see from here. So this is the text file converted from BAMAS. As you can see, that text file is separate the first and second column by tab. So you can see that so first column is binding energy, second column intensity, separated by tab. So the one Bamas file sometimes multiple spectral data included. In this case, 5 spectral data is involved in this single Bamas file. If you want import data from the other file like multipack, so as you can see, this is also 5 spectral data involved in one NPL file, and carbon 1 is data, oxygen, sulfur, nitrogen 1 is molybdenum 3D. As you can see that. Then if you have many data, you can also clear the list. Then you can clear. But you can still import the text file, as you may see that is already converted to the text file. So next time you can just choose one by one, or open directory. It's not this example. So all the text and CSV file will be imported, as you can see that here. Yeah. For example, we have carbon 1s, preset carbon 1s, evaluate, okay, to fit, and you can save the fitting parameter file. This, okay, something preset, so you can save. Then if you have another carbon 1s data, then you can load that carbon preset data. Of course, intensity and peak position might be changed, but you can easily start the peak fitting for next spectrum. And okay, back to carbon 1s again, fit, then you can export the fitted data. Okay, so we will see what data exported. This fit, we have text file and CSV file. CSV file we can open actually in Excel, but it takes some time, so I just open as a text file. So binding energy, intensity, original intensity, and fit sum, and the background data. The G1 is this spectra, and G2, G2, G4 spectral data all included in this file. So if you want to plot in Origin or IGO or Excel, you can actually plot the same picture. I may show you. So the other file exported is a text file. The text file inside has also some parameter file used for LG4X. It's not very critical, but if you want to see what lmfit command actually fit this data, so all the command actually produced in LG4X sent to lmfit, and the lmfit back to LG4X the fitted data actually all the thing. And if you want to see the standard error, you can also check from this file the peak position plus minus, how accurately estimated the optimize the peak position or peak width amplitude. You can have all data in text file. So the CSV file is directly open in the Excel. You can see, so it's separated by comma, so it's not possible data. Okay, so for example, you can choose whole column like this and insert and scatter data. As you can see that the scale is opposite, and the background data also involved. So, but the whole, each separate spectral data is actually available. You can reproduce the fit result in your Excel, and you can change the scale or the order of energy, so you can easily publish your data after fitting here, and quantize the element concentration, and you may have to have a sensitivity of each orbit. Like if you use the aluminum K alpha, you have to have relative sensitivity factor, probably get from this paper, and you can also see this website. You can see cross section. The cross section, you can get the data. Even the high hard X-ray photo emission spectroscopy is now available. Some places you can get the sensitivity factor, sometimes called photoionization cross section, available. So you can quantify your element on your surface or bulk in case of hard X-ray photo emission spectroscopy. And sometimes OJ appear, especially in soft X-ray, XPS. Then you can have also the database available from here. The binding energy I get from X-ray data book. You can actually download the PDF file, so number of X-ray data available from this website. And the detailed operation, the menu is actually all available from this website. I also developed some Excel macro program which called EX3MS. If you have Microsoft Excel, you can also fit the data only on the Excel. Macintosh Excel is not very efficiently work at the moment, so I recommend if you want to use this program on Windows only. But it's not possible to use this macro program on Mac OS, but not very efficient. So I recommend if you have Excel on Windows, you can do the similar thing as I present in this video. So this is a very simple introduction. The detail also I would like to talk about, but this video is already long, so introduction of this program is ended now. So thank you very much for your kind attention. And if you want to use this program and you want to cite the program citation, you can have DOI code from the Zanodot website. Thank you very much.